Hello viewers, welcome to my channel Second Math Hub, a solution to your math problems. Still on trig, angle of elevation. Question 5. The shadow of a vertical pole is 50 centimeters long. If the height of the pole is 2 meters, we have to find, correct to the nearest degree, the angle of elevation of the sun. So quickly, let's provide solution to this. So two things have been given here. One, the length of the shadow has been given, and then the height of the pole has been given. So even before we erect a pole, there must be a ground. Before we erect a pole, there must be a ground. There must be a ground. So we have our ground here, and then we have our pole here. So obviously we see that the pole here is meeting the ground at an angle of 90 degrees. It's meeting the ground at an angle of 90 degrees. Now, where do we locate the shadow of the pole? There is a vertical pole. From the question, the height of the pole was given as 2 meters. And then where do we place the shadow of this pole? So obviously the shadow of this pole will lie on the ground. The shadow of this pole will lie on the ground, provided, let's say, the sun is here. So let's say we have the sun here. So the shadow of this pole will be on the ground. And what is the length of the shadow? It was given as 50 centimeters. 50 centimeters. And we are to find the angle of elevation of the sun. So how do we create the angle of elevation of the sun? Meaning that we have to view the sun from this point. So from this point, we have to view the sun. We have to view the sun. And this should give rise to the angle theta, which is also the angle of elevation of the sun. Now, before we even start the calculation, you can see that the units here are not the same. The height of the pole has been given in meters, and then the length of the shadow has been given in centimeters. So even before we start the calculation, we must either convert all the units to meters, or we must convert all the units to centimeters. In my case, I prefer changing the meters to centimeters. So now we know that every 100 centimeters is equivalent to 1 meter. So if 100 centimeters is equivalent to 1 meter, then 2 meters should give us 200 centimeters. Should give us 200 centimeters. If 1 meter is giving us 100 centimeters, then 2 meters should give us 200 centimeters. So before we calculate for the angle, we need to identify the sides of the right angle triangle. So you can see that there is the longest side, that is the hypotenuse. We said that the longest side is the side facing a 90 degrees angle. Now which side is this? This side becomes the opposite, simply because this side faces the angle theta. And then obviously the remaining side will be the adjacent. So now from SOHCAHTOA, to calculate this angle here, we have to consider the opposite, and then the length here has been given, which represents the adjacent. So again, from SOHCAHTOA, which of them has opposite and adjacent? So that is TOA. And what does TOA say? So in reference to this right angle triangle, it means that the tan, okay, let me do it here. It means that the tan of this angle here is equal to the length of the opposite. The length of the opposite, in this case, it was given as 200 divided by the length of the adjacent, which is 50 centimeters. meters. So what are we looking for? We are looking for theta. So we have to take the tan inverse on both sides. So taking the tan inverse here will cancel out the tan, leaving theta on the left. And then we have the tan inverse of 200 divided by 50. So the rest is calculator work. So from our calculator, what is the tan inverse of 200 divided by 50? The tan inverse of 200 divided by 50. So to 2 decimal places, that is giving me 75.96 degrees. But again, we are asked to correct our answer to the nearest degree. So to the nearest degree, as we can see, theta, we can round 75 up by 1. So that should give us 76 degrees. So in conclusion, the angle of elevation of the sun measures 76 degrees. Thanks for watching.